Hello everyone. First of all, I convey my sincere gratitude to the principal sir, conveners and all the organizers for conducting workshop on an extremely important subject of a great practical value and also for inviting me to be a part of it. Today we will glance through the role of various statistical software that are currently being used in data science. In today's world, just merely putting forward our hypothesis or facts may not validate our point until we back it up with some analytical support or strong statistical analysis. And for this, these softwares play a very crucial role. Let's start by adding up some numbers. There are two ways to do it. Either one can do it manually or can make the use of calculator to get the result. The later approach will yield result very fast with least amount of effort. Summing up of the data was very easy, but manually calculating something like the descriptive statistics or any other statistical parameters of large data sets generally become very cumbersome and they are usually prone to errors. Even a small error can be very significant and can change the inference of our analysis altogether. Now, with the advent of these statistical softwares, uh, just like any other machine, uh, one can not only calculate these descriptives faster, but also do it more precisely and in a more fashionable way by making interactive graphs. Hence, there are several benefits of statistical software over the manual handling of the dataset. First 4 points we have already discussed. Coming to the fifth point, softwares gives us an option to store, retrieve, maintain, and analyze our dataset whenever needed. So they acts as a repository for the large datasets. One can easily compare two or more datasets with these softwares, and we can use a lot of interactive ways like graphs, plots, charts, etc. to represent our analysis. Moreover, use of these software reproduces the same result no matter whoever is doing it until it is done as per the fixed algorithm. So these these analyses become reproducible. Now, these days one can find so many softwares available in the market that can be employed for data analysis, like SPSS, R, Minitab, Stata, SAS, SigmaPlot, and many other software. In present session, I will be concentrating on three software which are commonly used for the same purpose. First is Microsoft Excel, which I believe most of us will be aware of. The other two software, SPSS and R, may be new for some of us here, but I'm sure that you all would become quite familiar with these two tools after completion of the entire module. So let's begin with comparing these three softwares. First parameter for comparison is user interface. Let's go directly to different softwares and try to understand them. Microsoft Excel in true sense is not a statistical tool, but it is simply a spreadsheet where we can also perform several statistics up to a certain level. Now these numbers on the left panel represent different rows and these alphabets on the top panel represent different columns. Each box is known as a cell where we can add our values. The interface of Microsoft Excel is known as GUI, which is graphical user interface. It provides several different drop-down menus, and most of these drop-down menus are associated with organization of dataset. The tabs where we can perform our statistical analysis are Formula tab and Data tab. In Formula tab, we can perform several mathematical functions along with some statistical functions. Another way to perform analysis on data is under the Data tab. In this Data tab, we have to activate this window, which is known as Data Analysis window. This window is activated by the add-in menu, which is in the file and inside options. And in this, we have to select add-in menu and then analysis toolbar. After this, this data analysis window is now activated. Now under this data analysis window, there are several statistics which we can perform, and it covers almost all of them. We can either insert our pre-existing file into this software, or we can just type our dataset into the spreadsheet. Now let's say we have to perform a simple statistics like a descriptive statistic like average, standard deviation, mean. So how to go about it? So let's for entering any formula, we can go to either Formula tab and select more function, and under statistic, let's say we select average. Now we have to provide the data set on which we need to get the statistical analysis done. So we select our dataset, entire dataset, and say OK. So it will provide the mean of these dataset. We can perform the similar function by typing equal to symbol and then writing the required statistical analysis. Suppose average. So we have to select this average, then select the dataset on which we have to perform our test and then close the bracket. Now, by both method, one thing is important. We need to select our entire data set to perform this function, to perform any formula. So this is a basic interface of Microsoft Excel. Now let's understand the interface of another software which is known as SPSS. SPSS is a powerful statistical software suite which is developed by IBM for advanced statistics and handling large data set in particular. SPSS stands for Statistical Package for Social Sciences. The interface of SPSS is similar to Microsoft Excel, which is GUI, graphical user interface, but here the column tab is common, and these column tab is known as variables. This spreadsheet of this SPSS is known as data editor. We can type our data set directly, or we can import data from either from Excel or any other software, or we can open a pre-existing data set. Now, this data editor window has two tabs. One is data view, another is variable view. In data view, it is used for data input, and in variable view, it is used for adding variables name and defining their properties. Menu bar at the top provide access to various commands which are grouped according to the function. So you can see various commands that are grouped according to several functions. This toolbar generally represent the commonly used shortcut commands that helps us to sort and arrange our data, organize our data set. Uh, Most oftenly, the three tabs that are used for analysis of the data sets are transform tab, analyze tab, and for visualization of data set, we can use graph tab. Let's open one pre-existing data from Excel file. Uh, Now we can check this variable which says that read variable name from the first row of data, and after checking this box we can click on OK, and the data now get inserted into the data editor window, and the variable name is now changed accordingly. Now let's understand the interface of another software which is known as SPSS. SPSS is a powerful statistical software suite which is developed by IBM for advanced statistics and handling large data set in particular. SPSS stands for Statistical Package for Social Sciences. The interface of SPSS is similar to Microsoft Excel, which is GUI, Graphical User Interface, but here the column tab is common, and these column tab is known as variables. This spreadsheet of this SPSS is known as data editor. We can type our data set directly, or we can import data from either from Excel or any other software, or uh, we can open a pre-existing data set. Now, this data editor window has two tabs. One is data view, another is variable view. In data view, it is used for data input, and in variable view, it is used for adding variables name and defining their properties. Menu bar at the top provide access to various commands which are grouped according to the function. So you can see various commands that are grouped according to several functions. This toolbar generally represent the commonly used shortcut uh, commands that helps us to sort and arrange our data, organize our data set. Uh, Most oftenly, the three tabs that are used for analysis of the data sets are transform tab, analyze tab, and for visualization of data set we can use graph tab. Let's open one pre-existing data from Excel file. Uh, Now we can check this variable which says that read variable name from the first row of data, and after checking this box we can click on OK, and the data now get inserted into the data editor window, and the variable name is now changed accordingly. Now let's move on to other software which is known as R. R is basically a programming language and environment for statistical computing and graphics. It also provides several machine learning algorithms. R generally comes with command line interface. That is, we need to write command for performing every task within this software. It has a very less scope for graphical user interface, and most of the graphical user interface support is provided by another software which is known as RStudio. RStudio generally has three windows. First, it has a console window, and in second tab you can see one window where we upload our files, which shows the file which are uploaded in this console, and in third window we can see all files in the directory folders. Then we can visualize our plots in a separate window, and uh, unlike unlike SPSS and Excel, where functions are defined and organized under a specific commands, in R, because it is a programming language, we need to upload certain packages to perform our analysis. Now the most commonly used packages for statistic are dplyr, and for visualization of graphs we use ggplot. Now we need to install these packages from a repository. R has a big repository, and we can, there are lots of packages inside the these repository. So we need to type dplyr, and I just say install, and also for uh, and similarly we need to install ggplot ggplot for graphs. Now after installation we need to upload these packages into the console. So for this we go to packages. These are all the installed packages which are present in our software. So just we need to check these packages. So we need to uh, if we check this box, then this dplyr packages get installed inside the get loaded inside the console. Similarly we need to click ggplot2. Okay. uh, Now we can either write we can either create a vector that is such as like a equal to, suppose a is a vector and a equal to column has names 1 2 3 4 5 6 8 9 and 10. So if we want to view our vector, we just type a and we can see the numbers inside it or data inside the vector. Another way is to import our dataset from these files, either from text file, from Excel, or from any other software. Let's say from we can upload our data file uh, from Excel, and import. So this is the basic graphical interface that is provided by RStudio, which is not provided by CRAN, and we have to write everything down in this uh, while if we are using the R CRAN console. Also, one benefit of RStudio over R CRAN is that uh, it provides suggestions. Suppose if we need to find out mean, so it will provide different suggestions and way to perform this function. For example, if we say mean of let's say this corn, so we need to write the file name test and select the column, and it suggests which column we need to select. So if we say, let's say we say wheat, so mean of wheat, it will provide a number which is a statistical mean or arithmetic mean of this data set. Similarly, we can find out the standard deviation by writing the command sd and entering the file name test By entering dollar symbol, we can select the column name. Let's say wheat. So it will provide the standard deviation of that particular column. Similarly, if we need to perform different test, we need to write the command for that particular test. For example, for ANOVA it is AOV. For t-test it is t.test. If we don't know how to write the proper command for a particular test, we just you can just enter question mark and write the name of the test, suppose correlation, COR, and press enter. You will see that this software will provide help documentation for that particular test, wherein you can see how to write the command, an example to how to write a command for that particular test. Now let's summarize this user interface for these three softwares. So basic three software user interface in three software. In Microsoft Excel and IBM, the user interface is simple graphical user interface, GUI, which is easy to use and user friendly, and also provide simple drop down menus. While in R, it is basically a command based software, or it is a programming language. Now in Excel we need to select the entire data set, and the output is generally we can get output generally in the same spreadsheet, while in SPSS there are several different files for, let us say, we can convert these columns into vectors, and there is separate file for saving output, and it is more organized. And while Excel is basically acts as a spreadsheet, however SPSS is basically a more advanced statistical software, whereas R also provide different tabs for visualizing plots. However, the analysis of uh, data and results are provided in same tab only, same console tab. So this is the basic difference of user interface between these three softwares. Now let us move to second parameter, which is language. SPSS and Excel is written in best-in-class GUI which is written in Java language. Best in class GUI platform, which is Java. While RStudio is written in a more object oriented programming facility, which is known as C++ and Fortran. Therefore, these two softwares are very much user friendly and it is easy to understand. However, R is difficult to understand, but we can explore many capabilities within the R. Now, moving on to cost, MS Office generally comes pre-installed in computers nowadays, and the basic home and student version nearly cost 5,000 rupees, while IBM SPSS cost us nearly 10,000 to 20,000 depending on the uh, advancement of the software package. And R is basically a GNU based openware. That means it is available free to use. We can download R free from its official site, and also all available packages are always free to use. These packages are like application in mobile phone. Each package has been developed or designed in this programming language for specific purpose. For example, for statistical analysis, we have different package. For visualization of data set, we have different packages. Similarly, for phylogenetics and bipartite interactions. A GNU based free alternative is also there for SPSS, which is known as PSPP. It has a similar tabs as that of SPSS. If you can see that the spreadsheet is quite similar to that of SPSS, and it also has these two tabs, data view and variable view. Also in menu you can see transform, analyze and graphs options, but uh, uh, but in PSPP it does not provide advanced statistics. However, most of the required statistical analysis and functions are available in PSPP. Moving on to data management. Excel and SPSS provide a very easy platform for managing the dataset, especially while tracing for errors in the data. Data management is relatively difficult in R, and for this we need to import dataset from other file formats such as CSV, text file, or Excel file. We can also import dataset from other software such as SPSS and SS. So basically the data management is quite tough in RStudio. So we need to enter our data in some other software and then import our dataset into the R. Now next important parameter is data visualization. MS Excel and SPSS generally provide very basic visualization of data. So it has very basic graphs, basic plots, and these plots we can easily uh, and they have some limited number of plots. Now moving on to data visualization, Microsoft Excel and SPSS generally provide very basic or very fundamental visualization of dataset. However, R has several packages for data visualization, and most common of them are ggplot2 and color picker. which can be used to these packages can be used to make highly advanced and interactive form of graphs. So in R we can make highly advanced and interactive plots. Now, handling large data sets generally takes a lot of time in Microsoft Excel. The data processing is very slow. Also, there are few hundred functions only that are available for analyzing our data set in Microsoft Excel. While SPSS and R provides a better platform for analysis of large data set. Also, R has several thousand functions under different packages. So Microsoft Excel are basically uh, provide difficult for large data set, for handling large data set, while SPSS and R both can handle very large data set. And there are few hundred functions, while in R there are several thousands of functions, which are much more than SPSS and Excel. Now, Excel has generally a very limited support base and also which is provided by Microsoft Community. SPSS, on the other hand, has an extensive support base in IBM. But both Excel and SPSS generally charge for their services. So these are paid services. While R has a large support based community for developers that provide free support in their discussion form. So it has their own discussion form where one can post their query, and generally the programmers help in resolving that problems, and it is absolutely free also. Now, Excel generally updates its GUI platform, and more or less that update is um, based on the designing of the software. However, the analytical part more or less remains the same. SPSS update its version continuously but charges heavily for the latest version and their updates. However, R is a programming language, therefore millions of programmers keep updating uh, their packages either by modifying their packages or by designing new packages altogether. So now if we look into the popularity among these three, R language has been increasingly used by the data scientists and programmers all over the world in recent years. Also, in most of the research articles, the usage of R has been significantly increased over the period of time, while the other softwares are on continuous decline. Now, let's summarize the comparison between these three software. As per difficulty level, Excel is easiest to understand because we are using it since our childhood days. SPSS provide moderate level of difficulty, while R is most difficult among the three. Uh, Excel and SPSS both provide graphical user interface in a drop-down menu-based system, which is easy to understand. While R provide a code-based, command-based interface. Excel is cheaper than the SPSS, which is very expensive, while R is a GNU-based software and it is absolutely free. Moreover, their packages are also uh, are available for free. An alternative of SPSS is PSPP, which in which we can perform many statistical analysis which are required. Excel can be used everywhere in many field, but it is not specifically not necessary. It has been used for statistics. Our usage of R is continuously increasing over the period of time, and in for SPSS it is has high usage in psychological studies. Microsoft and IBM both are paid support. They provide paid support to their customers. However, R being a programming language and it has its own uh, discussion platform where everyone can answer each other's query and help in solving the problems. Microsoft Excel is best for its graphs. It provides some basic binary levels of graphs, uh, uh, while R is for cutting edge technology, and it provides it is better for visualization. It has several packages for statistical advanced statistical analysis can handle large data sets, and it is continuously evolving. Also, SPSS is entirely made and built for statistics only. So these three softwares are generally that are available and heavily used in our um, in our analysis of data set. So computer-based software provide faster, more precise, and easy handling of data. They provide extensive analysis and better visualization of data as compared to manual analysis of dataset. Excel and SPSS are employ a simple graphical user-based interface, while R is a programming language and a use command line interface. Handling of larger data cell in Excel is very difficult, while SPSS and R provide better platform for handling larger data sets. Utility of R is being continuously increasing as compared to other softwares, as it is a cutting edge technology provide amazing capability for data scientists and learners. That's it from my side. Thank you for your time. For any queries, you can contact me on my email ID. Thank you so much.